theorems, as well as its examples. Then later on, we'll have some exercises. As with ordinary limits, this concept of limit at infinity can be made precise. Roughly, we want the limit of f of x as x approaches to infinity is equals to L, to mean that we can make f of x as close as we want to L by making x large enough. Let's have definition first. Let f be a function defined on c and positive infinity. For some number c, the limit of x as it increases without bound is L, which is written as the limit of f of x as x approaches to positive infinity is equals to L. If the values of f of x get closer and closer to 1 and only one number, L as x becomes larger and larger. Let me show you the illustration. Consider the function f of x is equals to x plus 5 over x plus 2. First, we need to complete our table of values. Since we are approaching to positive infinity, then our x will get larger and larger, as well as the value of f of x. As x increases without bound, f of x approaches 1. Thus we say the limit of x plus 5 over x plus 2 as x approaches to positive infinity is equals to 1.
Similarly, let f be a function defined on c and negative infinity for some number c. The limit x of as decreases without bound is L, which is written as limit of f of x as x is approaches to negative infinity is an equals of L. If the values of f of x get closer and closer to 1 in only one number L as x becomes smaller and smaller. Let me show you the illustration. Consider the function of f of x is 4x plus 10 over x plus 4. Again, we need to complete the tables of values. So, ang pag-solve sa table of values kay ninganion lang. F of negative 1 is 4 times negative 1 plus 10 over negative 1 plus 4 is an equals of 2. So, ninganion lang siya pag-solve hantod sa negative 10,000. So, as x decreases without bound, f of x approaches negative 1, thus we say limit of 4x plus 10 over x plus 4 as x is approaches to negative infinity is an equals of 5.
Solving its limits takes a longer time to solve using the table of values. That's why we do have theorems to take shorter time solving or evaluating. So let R be any positive integer. The limit of function 1 over x raises to r as x approaches to positive infinity is equals to 0. The limit of the function 1 over x raises to r as x approaches to negative infinity is equals to 0. Let me show you an example. The limit of the 3 over x raised to 5 as x approaches to positive infinity. Although it's different from the theorem, however, we will separate its numerator 3 and denominator x raised to 5 for us to obtain the theorem. So the number 3 will be separated and the numerator will change automatically into 1. Since the limit is approaching to the larger unit or positive infinity, the whole 1 over x raised to 5 will be equal to 0. Since the theorem clearly states that the limit of 1 over x raises to r as x approaches to positive infinity is equals to 0. So it will become 3 multiplied by 0. So the limit of the 3 over x raised to 5 as x approaches to positive infinity is equals to 0.
Now, let's proceed to the next example. The limit of 7 over x cubed plus 2 over x as x approaches to negative infinity. Again, let's apply the theorem. Separate the numerator to its denominator 7 over x cubed is equal to 7 times 1 over x cubed equal to 7 times 0 equal to 0. The same in 2 over x is equal to 2 times 1 over x equal to 2 times 0 equal to 0. So the limit of 7 over x cubed plus 2 over x as x approaches to negative infinity is equal to the limit of 0 plus 0 as x approaches to negative infinity is 0.
Let's have some example that is more advanced and needed some manipulation. The limit of 5x plus 4 over 3 minus x as x approaches to positive infinity. In this problem, we will manipulate it. We will multiply the function to the highest exponent. The highest exponent is 1 since x raised to 1, so the limit of 5x plus 4 over 3 minus x times 1 over x over 1 over x as x approaches to positive infinity is equal to the limit of 5x over x plus 4 over x over 3 over x minus x over x as x approaches to positive infinity. So we will cancel both x from 5x over x is equal to 5. Same in x over x is equal to 1. Next, we will apply the theorem 1 over x both in 4 over x and 3 over x. We have here 4 over x, so 4 and 1 over x is equal to 4 times 0 is equal to 0. And the same here in 3 over x is equal to 3 and 1 over x is equal to 3 times 0 is equal to 0. So the limit of 5 plus 0 over 0 minus 1 as x approaches to positive infinity is equal to 5 over negative 1 is equal to negative 5.
Let's proceed to the next function, limit x squared minus 6x plus 1 over 3x minus 7 as x is approaches to negative infinity. In this case, our highest exponent is x squared. However, the denominator do not have x squared. So we will not considering the x squared instead. The negative 6x from the numerator and 3x from denominator. So limit of x squared minus 6x plus 1 over 3x minus 7 as x is approaches to negative infinity times 1 over x raised to 1 over 1 over x raised to 1. This is what we do when we have different highest exponent from numerator and denominator. Limit of x squared minus 6x plus 1 over 3x minus 7 as x is approaches to negative infinity times 1 over x raised to 1 over 1 x over x raised to 1 as an equals of limit of x squared over x minus 6x over x plus 1 over x over 3x over x minus 7 over x as x is approaches to negative infinity. We will cancel x from 6x over x. The same here in 3x over x. And apply the theorem here in 1 over x and 7 over x. So we have limit of x squared minus 6x plus 1 over 3x minus 7 as x is approaches to negative infinity times 1 over x raised to 1 over 1 over x raised to 1. So equals of limit of x minus 6 plus 0 over 3 minus 0 as x is approaches to negative infinity is an equals of limit of negative infinity minus 6 plus 0 over 3 minus 0 as x is approaches to negative infinity. Since we are approaching negative infinity, so the x will become negative infinity, and as we evaluate it, negative infinity is very large number. Even if we add numbers and divide it, still it is a large number, so limit of x squared minus 6x plus 1 over 3x minus 7 as x is approaches to negative infinity is an equals of negative infinity.
That is the end of our tutorial. Let's have some exercises. For you to practice, we prepare some exercises for you to solve. Do not worry, we will show you the answers at the end of the video.